all engineers, scientists, we have the statistical tools of mathematics to play with, and we believe in trying to do some reasonable extrapolations. And if we do that, there are two very famous extrapolators. One is the learning curve, right? So that is also called as the learning curve theory, right? So if you use the learning curve theory to project and predict this microprocessor performance, then if you look at the data which was observed between 1978, next slide. If you look at the data that is observed, next. Yeah, if you look at the data that is observed between 1978 to 1995, then in that is case, if you are adventurous enough, you can extrapolate it to 2020 and step beyond. You will be able to see that Gordon Moore was able to predict, based on its growth, that the performance doubles every 18 months. That was his prediction, but in fact it did every 15 months. And at the same time, the performance doubles, but the prices stay the same. Go back to the previous two slides. Yeah. So therefore, this is what it says. Now, go to the next slide. Now suppose I use these two learning curves and Moore's law to predict what would be the performance and extrapolate that right up to 2020. Next figure. Then you will see, I'm sorry that it's a bit blur because I had to scan it from some IEEE paper. Then you will see that by 2020, the learning curve predicts that the performance of the processor will be hitting 11 million instructions per second. And by Moore's law, it will be hitting about 2.7 million instructions per second, the thicker line. That's around 2020. Previous slide. Now you go back and look at the scenario right from 1970 onwards, and look at the scenario at 1996. The SICRA processor was only giving you an output of 250 MIPS in 1996, right? So the predictions according to the learning curve is 44,000 times improvement, and by Moore's law it is about 10,000 times. Now the question to you all is that is this possible? Right? And the basic fundamental question which comes from physics, whether is this sort of an improvement possible? We have not even hit 1 million instructions per second mark in these processors and devices, and in 1997 we are still at 250, and somewhere now it has escalated a bit more. We talked about I4 and I5 and so on and so forth. So therefore, according to physics, that answer is clearly no. And thus, Moore's law doubling with every successive generation of systems which come out, right from your simple 8085 to 8086, and then the bunch of 8080s which became 888, and Pentium and processors and so on and so forth, which had all Ethelon and microprocessor and Zilog and Z, so on and so forth. It is not possible. So therefore, the Moore's law doubling as per the predictions may not necessarily be true, and it is not, and it is likely to slow down, and it has. Unless and until there is a breakthrough. So therefore, the microprocessor may be a brief one. And that's the reason why I said in the right perspective, it's a transforming device. So forecasting is basically an unreliable science, right? Particularly when exponentials are involved. If it is linear, y is equal to mx plus c. Is fine. But y square is equal to 4ax. Para and hyperbola is very difficult. Particularly when it is almost the near edge. And that's where the challenge and the problem is. And that's where we fail. The conventional algorithms, which were non-linear, which could still be modeled by breaking into piecewise linear and summating them rather than integrating, and still get out. But now there is a new type of evolution in the algorithms. Soft computing, computational mathematics, non-linear, which are highly sophisticated and perhaps very difficult to arrive at solutions. It is something like this. A group of pigeons come and sit down here, and they're all moving in random directions to random places for doing anything. Can you find and devise an algorithm where that pigeon X at a location X comma Y will be moving to a location delta X comma Y in a period of time? That's the type of challenges which are coming. Forget the non. Where is the non-linear? This is highly rigorously non-linear. Soft computing is a domain in this. So therefore, can you go back to the slide? That another one? No, the graph. The graph. Yeah. So therefore, particularly when the exponentials are involved, if you see here, 2010 is there, and the one which is on the thicker one, 2.7 mmIPS, is what your Moore's law predict, and you can see that there is a rapid ascent of 1 million instructions per second when it will jump, a quantum jump between 2019 to 2010. And there you can see, according to the learning curve, it will jump to 11, 44,000 times, and this one 10,000 times. Now the question is it possible? And where is the real estate? If at all you have seen the chip, where is the real estate? That is the number of chip or the density functions per unit area, which define what's the computing or what is the capability of your processor. How much you can imprint and imprint and make in one small this one. It's the number of transistors. Microprocessor is nothing but a well-organized switch. It's the number of switching elements which switches in tandem in some manner in order to produce an exquisitely superb output. So therefore, the question is, now compare this time, by the time it has taken to reach, no, go back to that slide. Yeah. Now you compare this, 250 is MIPS is the SICRA processor in 1996. Now you start at 1970 and you see somewhere around 2015, we will be hitting the 1 MMIPS mark. 35 years it has taken and will take to hit the 1 million instruction per second mark. And having said that, going immediately by 1 MMIPS 2.7 is something which needs to be reconsidered and rethought of. So processor performance, when this type of performance capacities are knocked or called for, it really takes a lot of things. So therefore, Moore's law doubling or having this is perhaps difficult in the next generations to come, and that's why it might not be. So the performance will slow down, and that's the reason why we want to go next. So what we call this as speed bumps. You have an expressway, and and then you have a bump. All of a sudden you are going at 120 and then you have a bump. Oh. Right? So this is something like that. So therefore, the depth of microprocessor is certain. We are heading towards it. Next slide. So now, what is it? We are miniaturizing. It is the era of miniaturization, consolidation, and integration. The GNR revolution, genetic engineering, nanotechnology, and robotics are one comprehensive whole. It's there. So, the chip miniaturization will continue up to the third half of the 21st century as we transcend. And this is where exactly I am telling you we will transcend from MEMS to NEMS. 10 to the power of minus 6 to 10 to the power of minus 9 meters. Right? MEMS is micro electromechanical systems. Where still we didn't bother. But when you talk about NEMS, the landscape of physics changes, and that is where forces such as friction, etc. becomes very important. And these forces act at 10 to the power of minus 9 to minus 12 Newton meters, if physicists want to know it. So nanotech, if I want to define here in just one sentence, it is building atom by atom molecules that will have functionalities or a portfolio of a device in order to affect and accomplish a certain task. A salt, if you break it down to nanotech, it becomes poisonous because you displace of the atoms and it reconstructs and reforms to another engine. So these are much more dangerous than any other things. They are like invisible bullets, nanoparticles. Anyway, we will not get into that now. That's beyond the scope of this presentation. However, now, as I said, this miniaturization process is likely to continue until the second half or the third decade of the next 21st century. And essentially, this process will end. And when the process ends, it will be taken over by steady improvements in the software engineering technologies, which will give it a further push. It will be at its peak. And when you kick into the picotech, that is 10 to the power of minus 12, your cyborg is there. That's for true. And that's the reason why I said that matrix is for real. By 2025, this humanity would have developed what is called as an anti-technology culture. And there will be a group of people who will be fighting with this one. And then a lot of issues. So therefore, and the robots, they will be taken as your companions, and by 2035, 2030, they will be given the first civil rights. It's going to happen. They'll be given the first civil rights, and they'll be thought as companions, not as computers. Well, so now if you look back into the physics part of this, why this will fail? Because there is no real estate left. You are already playing with the atoms, with the structural configuration. The moment you alter, physicists will tell you, any of the structural configuration or its composition in the lattice atoms, you will find, read Kittel, you will find that its properties have changed, which includes electrical,